Here we go.
Yes, I can see it. All right, then I will just start sharing my screen. Start with this. So yeah, hi everyone, and welcome to Tables Done Right, how to use the c8y-data-grid, which is a part of the Web SDK. So I'm Hendrik. I'm a software engineer and IoT consultant nowadays, it's called, for over 10 years for the Software AG. Previously worked on mobile solutions, so developed on iOS, and now for since Cumulocity started, so to say, for us, the whole journey, I was participating on UI development, and nowadays I'm usually kind of like a tech lead, so to say, in UI when it comes to UI projects and project development. So I have used the c8y-data-grid quite a bit, and I wanted to share my experience with it, as I saw and I can fully understand that it can be quite overwhelming if you want to use it, let's say, properly. Why I'm telling properly, I will tell you later. So let's just first dive in and check out here in the chart, where is it, what is it part of? So as you can see, it's a typical Cumulocity's Web SDK chart, so to say, where you can see all the parts of it, and the data grid rests inside the c8y NGX components, meaning whenever you create a cockpit clone or create an empty Web SDK-based application using the c8y CLI, you will get components and building blocks, so to say, for free directly from the NGX components. And one of these building blocks is the c8y-data-grid. It's available since version 10.7, or I think it was even before that, but it was kind of buggy, so to say. And in the recent updates of the Web SDK, it got improved and got better and better, and the layout was improved, since it's also having a responsive layout. Yeah, and right now it's a very highly flexible framework kind of to use, and I want to show you that now. And let's just dive right into the features of this and how this is, how the principles of that are. So here you can see an image of the c8y-data-grid, where it's actually being used in a very minimal example, so to say, where you just have two columns, one for showing the ID of, I guess, some devices, and also the names of devices. And you can get already the idea what it is capable of from this screenshot, because you can see that you can have sortation, you can have filtration, you have a reload button, you can configure columns, meaning you could potentially change the order of the columns that you can see. You can even hide columns. You can clear all the filters that are applied per column on the top. You exactly can see how much items match the current filters and how much are there in total if you would clear the filters. All of that is available for you. And let's just check if I forgot something. Yes, what you cannot see right now is the callbacks for actions. So you can also have like multiple select, that you could select multiple of these elements and could then, for all of them, could apply, for instance, a delete action or something like this. That's also possible. And if we just go further in that regard, what you would start with, if you would start with developing a c8y-data-grid, is you have like two places where you can configure that. One place is the column configuration, so where you really define which is the first column and the second column, which name should it have, and what kind of data should it show. And of course, the c8y-data-grid HTML definition, so to say, where you can not only specify that column definition, but also where the data is coming from, how the general layout should look like, stuff like that. That's what we're going to talk soon in the next slide. And when we come now to the setup of the columns, I mean, I can also just quickly show you a live example, so to say, where we would just check out, it's this issue again. One moment, please. I cannot see my mouse here. So you can see here, for instance, I have a method here, get default columns, and it's returning me a column definition. And in there, you can see the typically used attributes. where the most important and the required attribute for a column definition is the name of a column. So for instance, the name column that's just displaying the name of a device would, I guess, have the name, and it has to be unique. So you cannot have two columns that have the name, because then, yeah, the Web SDK would literally crash and would complain about that. It's like a unique identifier and required, as I said. So you really need to specify that. And then all the other attributes kind of are optional, and it's up to you whether or not you want to use them. And this already shows a bit of the flexibility that you have. You're not forced to do much, but it's free how you want to use it. And that's also typically the way of the whole data grid, how it's set up, that it's up to you what kind of content you want to show, how the how the columns should be ordered. Also the layout of the cells of the grid can be customized, or filter views, things like that. We will cover that later on. So it's very flexible, the c8y-data-grid, and this goes down already and reflects kind of in the column definition. Because here you can, but must not, can specify, for instance, a header, which would be the text of the column that you can see here on the top. For instance, here, this minimum data example does not have a header specified. That's why it's falling back, so to say, to the name attribute and just showing the name attribute here. Let's just jump back. Then the path specifies, so just imagine you have an array of data, typically kind of complex objects, so not just an array of numbers, but really objects that have attributes, like a device. So a managed object, for instance, in Cumulocity speaking, and in there you, for instance, can find the name attribute, which is a string attribute, and you would here, using the path, you can specify which attribute that the value should be shown, so to say. So meaning, if you specify now name, it will always read the name attribute for every entry of your data set. And then a lot of other attributes. For instance, you have you can specify whether or not a column should be sortable or filterable. Interesting in that regard is, and I want to go just want to go back to my slide so that you can also see it here by text. You have to know that, because it's a bit quirky, to be honest. It's by default, every column is sortable. So this is by default. If you do not specify it yourself, it will be set to true. And by default, filterable will be false, meaning if you set up a column where you do not specify that explicitly, it will be by default sortable, but not filterable. That's how it is set up by default, behind the scenes, so to say. Also, other attributes that we might or might not cover later, let's see, is the types. You could specify what kind of information do you want to display in such a column. Is it a very long text? Is it just a number or something? You can specify it using the type attribute, but don't need to. And you have customization attributes, where you could set a custom cell renderer component, or also could set up a custom filter for your column. Meaning, if you would, for instance, if I just quickly jump to some more complex example here, you can see here are, for instance, custom filters. So this one is, for instance, a custom filter, and it was specified using some specific attribute, and then the component will show up that is specified with that attribute. While I'm showing you this here, I want to emphasize that you please check out the following repository. I mean, you can also find working examples of the data grid now in the tutorial application. Sorry, if you check out, if you would update and would not use the c8y CLI in version 10.11, but in version 10.13, there will also be more more sophisticated examples of the data grid will be included in the tutorial app. But since we already made up the work to have also another project, I just want to give you the URL for that. Let me just quickly go to the presentation here. I just want to give the URL for that. This is the project that I'm currently showing to you when I show you these examples here. So you can just also go to the repository. It's open source, and you can just download that, run npm install, specify some tenant, run npm run start, and you can also have a look on these examples. And what you can find there, just quickly, so that you know, is kind of a minimum setup example, but also more sophisticated examples. So one where you have a bit, more elaborated column specification, as you can see here. One where it's using a remote data source, meaning it's using real pagination and it's fetching just chunks from the Cumulocity tenant. And then also a customization example where the data grid looks a bit different, has some custom cells and custom filters in it. And that's all what you can find inside of that repository, as well as, and it's also where we will come to later, a query playground, because if you're using the data grid, you will also cover that in a second, is you will need to be aware how to create filter queries that if you want to target the Cumulocity tenant. Okay, but that was a lot of going forward already. So let's just jump back to the basic setup of the c8y-data-grid and go on here with the most minimal grid example. That's also the only example that you can find inside of this presentation now that covers the whole implementation of a data grid, because all the other examples are a lot more, have a lot more code. There's a lot more code necessary to set that up. As you can see, we specified the column definition here. So it's just one column showing you the name, and also just using the name path for the data set. It's so to say a hard-coded static data set here. So just 3 elements that have a name attribute, which is row 1, row 2, row 3. Some pagination is also being set up, and action controls are just empty. So we do not want any action controls. So no editing or deletion is required here in this minimum example. And you're already good to go. That's already a working, super good working c8y-data-grid here with just one column. And the problem with this local approach, so you can see, I just want to quickly jump back here. So you see we use the rows attribute. That's one way how you can bind data to the data grid. And that's also what I saw the typically used approach when using c8y-data-grid. Why is this a problem? Typically, what that means is that you would need to prefetch all the data that you want to show in the data grid. That's also how the data grid, I always called it like the local mode of the data grid. If you use the rows attribute, will be kind of the local mode of the data grid, meaning filtration, sortation, search functionality are out of the box working, and but are always done locally. While this is maybe cool if you know that the data set will always be kind of small, it's not, of course, not really good if you don't know if so for instance, if you're showing a list of devices, and of course you want the customer to be able to filter on all the devices and search through all devices. What that would mean if you would use the rows attribute is that you would need to prefetch all these thousands of devices, which takes a lot of time and slows down the UI a lot because of all the data you need to hold in the client. And so my recommendation typically is do not use this rows attribute. I know it's tempting because it's very easy to use, but typically you want a more flexible solution which can also handle larger data sets. And then the rows attribute is not the way to go. That's what I want to show you now, because instead of using the rows attribute, we will use the server-side data callback attribute, which is the other way how to bind data, so to say, to a data grid. What this means is that instead of prefetching data and just binding it using Angular binding to the rows attribute of the data grid, there will be a callback method that you need to implement out, so to say, and it's up to you what you want to wire up there. So you can wire up, of course, you can go against Cumulocity. You could also fetch data from a third-party source. It's up to you. So it's very flexible, this approach. But of course, and in these slides here, we will cover the Cumulocity approach, meaning typically you want to fetch something from the inventory and you want to show data from the inventory, query data on the inventory. And that's what we're going to do next. And here on this slide, you can also then again see what are the advantages. I mean, it's kind of the opposite as what you have heard about the local data approach, meaning you will have always a good performance because you will always just fetch a very little subset of data. Meaning, for instance, if your paging is set to just 30 elements per page, you will always just fetch 30 managed objects. And if the user applies some filter or sorts, it will always just fetch 30 elements and not more. Of course, if the user navigates through the pages, it would continue to fetch the other pages of data. But other than that, so it's a lot, the scalability is a lot better, and the performance, of course, also. Yeah, I mean, I already kind of touched that. What is the basic principle is that the filtration sortation will then be done on the server side. So the only thing we need to take care of on the client side is that we need to interpret what filters were set by the user, and then we need to create queries based on that, and these are then sent to Cumulocity, and the result data set will then be given to the data grid, back to the data grid. The disadvantage of this approach is, of course, since it's covering quite a lot, you need to know how to wire up this attribute, so to say. You need to know how to create these queries using the query language. You need to know kind of the c8y client, how to create queries and send them out, actually, which is also a different part, and handle the responses. So there are quite a lot of things going on that you need to be aware of. So the learning curve is a bit steep in the beginning. But since you now have already access to the public repository, you can already have a look on that for free, and you can already see how you need to set it up and how it works. So it's quite easy now for you. But please stay with me and just check out internally what happens behind the scenes. And this is explained quite good, I hope, in this slide here. So whenever a user whenever a user, for instance, loads for the first time the data grid that now uses the kind of remote data approach, what happens behind the scenes is that the data grid will call whatever is bound to this attribute, whatever is bound to the server-side data callback attribute. Typically, what I would do is that I would implement that method in an own service, so that I have it isolated, so to say, and I can reuse it across different data grids. And this method would be invoked inside of that service that I just specified on the data grid. And inside of that method, I need to create 3 queries. Why 3 queries? Because the data grid in its standard layout shows you quite some information. It shows you not only the result data set, meaning the data that you literally see in the data grid, but it also shows you some counts. It shows you the number of matching items and the number of total items, so to say. So 4 out of 18 items matched here, for instance, because I, in this example that you see here, on the name column, I set up a filter. And that's why only a subset is returned. And that's why we do not see 18 out of 18 items, but just 4. So it's pre-filtered. And yeah, so we need to create 3 queries. One query where we just want to get the result data set that is matching the filter. One query where we just are interested in the count of items that match the filter. And one query that would give us the count of items without any filter being set. So this is basically what we need to do, 3 queries. Just using the previous example, here you can see I set a filter with normal asterisk, meaning everything that starts with normal in the name should match. And now this is case sensitive, by the way, in Cumulocity, so always be aware of that. Now what the data source service is doing is behind the scenes, it's creating these 3 queries that you can exactly see here. So it's targeting the inventory API, creating a filter where it says name equals normal asterisk, and yeah, the rest is just what you configured. Then it's doing a page size 1 query and says with total pages true. And again, it's applying the query filter in the third REST call. And the page size is also being set to 1 with total pages equals true. Why is it like that? Because these on the bottom, these two are just the count queries, so to say. This is just some trick how you can retrieve the count of items. We'll also cover that later. Here you can see how you can actually bind, or how you can do the binding, because I also think in the first look, it looks a bit of a magic trick, to be honest. So you can see the c8y-data-grid HTML, you can see the server-side data callback attribute, and you can see here that there's some service that I injected in this component, and it has a method called server-side data callback. And in this service, you can see here on the other image that I have an attribute this.server-side data callback equals this.on data source modifier.bind this. What this does is kind of it enables you that you can bind a method as an attribute, so to say. So whenever the server-side data callback is being invoked from the data grid, what happens is that the on data source modifier method that you can see from line 15 to 17 will be invoked. Meaning, if you go a step back, the data grid will always call for data. It will always say, here, there was an update on me. I need to query new data because something has changed. And it's then your task to do this. You can also see the code, how it's typically implemented, such a method. Here it's called reload, this on data source modifier method, however you want to call it, it's up to you. But you can again see that that we need to create 3 queries. So the most for page, the managed objects for page, then the filtered count and the total count. All of these 3 will then be kind of run using the await promise.all. And the server-side data result will then be built together, so to say, and this will be then returned to the c8y-data-grid. That's just a basic approach how this works. And now you may ask yourself, but how do you know what filters are set and how the sortation is being set, stuff like this? And for that, one moment, I just need to go here to the slide. I think this is quite abstract, but this explains it quite good. What happens behind the scenes is that the grid will always keep track of what happens in the columns. So first you will provide the column definition, the grid will use this column definition, and then it will kind of extend these columns with its own data. And for instance, if a user sets a string filter that is supported out of the box, it would, for instance, use, I think, the filter predicate attribute or something like this. And so it's being stored inside of the column definition. And what happens now inside of such a data source service is that you need to iterate over every column. So in the end, your grid is just an array of columns, and you need to iterate over each and every column. And each and every column will tell you whether or not it's got sorted or it's got a filter set. And that's what you need to find out. And based on that, you need to create a query. So the basic principle explained. Regarding the count query, so I've seen that in the most recent updates of Cumulocity that some count queries got added. So it might be deprecated now to use this approach that I'm telling you now, but still I want to show you how we did it. Typically, if you want to fetch a count of something and you're interested in that, the trick is just that you set the page size to 1 and then with total pages to true, and whatever you're fetching, you're just interested then in the paging information, so not really the data that comes back, but in the total pages of the paging, because this will then tell you the exact count of, for instance, managed objects that managed your query. That's typically how you create a count query, just that you are aware of that, how we do this. And yeah, now we come to the filter queries. And okay, I think I should rather go here because this explains it, in my opinion, a bit better. What you typically need to do. So this is kind of like the approach when it comes to implementing out the data source. So like I already mentioned, you have the column definition, so an array of columns. And then for every column, what you would do is you would read out if there's a filter being set. For instance, it would be the external filter query attribute if you customly set something there. And for instance, here in this example, there seems to be a custom filter that said that the ID should be greater than 10. And what you then need to do is that you need to use that query language, let's just call it a query language, that Cumulocity supports and understands. This one, what you can see in the JSON. This then you can throw kind of into the build query method that ships with the Web SDK. And this will then generate the actual query string that you can see here, where it says $filter equals ID greater than 10. And this is then the query parameter that you're going to add to the filter object that you send along. So this is the last step, so to say, where you're saying inventory.list with some filter, and this filter will have the query attribute, which in turn will contain the filter string, which was in turn created using build query, which in turn you at first specified, so to say, what should be queried. And if we now look at this screen here, which I think looks a bit wild because there's a lot of information on here, to be honest, I don't want to talk about this just using the slide. I just would rather want to go again to the example that I already showed you and want to show the query playground, which got created here, because this kind of explains it way better than I could ever do. Because what this already has here is some potential view that you could set in such a custom filter for a data grid. And then also the JSON you would need to code, so to say, if you want to create a filter query. And also the output that would then go as REST call to Cumulocity. And all of that you can find here in the so-called query playground. Sounds more complicated than it is. Let's just imagine we have a custom filter or something we want to implement, and it should be a string filter, so to say. So we want to support that you could query for strings that start with some value, contain some value, or are equal to a value. And that's exactly what is implemented out here. So our fragment we want to filter on is the name fragment. You could also specify another fragment, like my custom fragment doesn't matter here. It's not really querying anything, but just creating these queries. So my custom fragment, and then starts with, and the text would be Hendrik, I don't know. So generate a JSON, and now you can see exactly what kind of a JSON structure you would need to code so that this would happen. So you can see whatever is the attribute you want to query against, so to say, is on the left side, then just a column, and then the search text. And since it starts with search, the asterisk would be at the end. If it would be a contains, and I would generate this, the JSON would still look quite the same, but just that another asterisk got added at the beginning. And if it's equals, who can guess it? Yes, no asterisk at all. And the query that would be generated by that would be filter equals my custom fragment. For instance, I could just change it to name, or I can also change it here. Name equals Hendrik. This is what would be sent out by the Web SDK. So this is nothing that you need to do. What you need to do is that you would need to give this JSON. Yeah, if we go back here, the JSON, into the build query method. And then this will generate a query, which you can see here. This is the query string. And this is what you will need to put into the filter attribute of whatever you want to query, since we are always talking right now about inventory queries, because only the inventory API supports that query language officially. We will fetch it using inventory.list. Yes, okay, let's just go back here. Just have a look on other queries that we could do. For instance, you could also query for numbers. So you could say, I just want to have managed objects with an ID larger than 10. That's what you can already see here. I would click build query. This would generate a query string. I guess you get the idea now. So we could say less or equal than 100. And you can see, okay, this will be the JSON structure you would need to code, so to say, where you have the attribute on the left side and then object inside of that again, where you specify the operator. So less equals it is right now. We'll change that to this, it would be equals, and then the value it should match against. You can do the same thing for dates. I guess that's also quite commonly needed, so to say, that you want to narrow down your data set of a grid using a start and an end date. And that's also what you can see here. So the start date would be the 4th of May and the 5th of May is the end date. If I generate that, you can already see how this looks like. Interesting is you need to append .date to these attributes. That's also documented in the query documentation that you can find. I think I already have that open here, the query language documentation that we have, that you would need to use the .date in order to filter on dates. And the query that would come out of that would look like that. And what you can also do, for instance, for enums, if you have like multiple choices and you say, okay, I'm just interested in these, but not in unavailable, apply, you can already see how this would look like, c8y-availability.status, and then using the in operation here. And this would be what comes out. So it's, just another way of ORing stuff. Okay, so since I'm too bad to really explain properly how these queries are being built in general, I hope this makes it more clear, the query playground, and please try it out. And yes, so this is basically what you would need to do if you want to create queries. Okay, already mentioned, this was just all of this was just against the inventory API. So if you intend to fetch managed objects, if you intend to fetch measurements or events or alarms, there will not be this query language. So all you can then fetch on or filter on, filter on are the typical query parameters that you have. So you could still query on date from, date to, whatever is specified. So for instance, here we are on the retrieve our measurements. So all of these query params that you see here are actually then also could be used by you to filter through the data set. So you could, for instance, have a source filter where you just say, okay, I just want to get measurements of device with ID 123. Or you could narrow down the data set again using date to and date from. That's just what we saw in the example of the queries. Just that you get an idea and a feeling how this works internally. And of course, you also need to create order queries where you specify which in which sort order the result data set could be. Out of the box, the c8y-data-grid supports sortation of multiple columns. We even got a request from a customer that they didn't want to have that. They just wanted to be able to sort on one column. And we needed to patch the c8y-data-grid in that regard because, it's not easily changeable. The default behavior is always that you can order multiple columns. Okay, we are already on the advanced topics. Let me check quickly the time. Okay, before I jump on any advanced topics, maybe let's just have a question round right now so I can, better narrow down what I might have missed. Did I already tell you what you wanted to hear, or did I forget anything? Do we want to have a look at some more real examples here in the code? Just let me quickly know, please. Hello?
I think they're good.
Okay. Yeah, since I have shown just slides, I would rather jump now into the code and just show it again. But really, how it's set up, just that, I guess all the missing pieces that you still might have and doubts that they come together. Let's just check out the remote data grid example from the public repository. So this would be this here, where you can see it's just fetching a list of devices. And what I will show you now is how is this being set up. You can see there are just two columns to keep it simple, so to say. You just see the ID and the name of all the devices, and you can also create a filter. Let's just quickly check if this works. So if I just say slow star, yeah, it does it. Okay. What I would first, before even jumping into the code, want to show you again is what I tried to explain with some of these slides, is what kind of queries are being sent out. So now I will just say a normal star. Okay, there are still these trackers in here, which is a bit obfuscating what I want to show. But you can see here, there are these three queries: managed objects query, where you can see there's kind of like a base query all the time, because what I'm showing you here is not the list of all managed objects, but really just of devices. That's why we have kind of a base query, so to say, where we are always querying for managed objects that have the c8y is device fragment. That's what you can already see just in the URL here. And yeah, of course, it's right now. Let's just quickly do just this. Okay. Let's just quickly decode the URL that you better can see that. And you can see there's a query here. This is kind of like the base query that I already mentioned. So it's always fetching for devices or for managed objects with the c8y as device custom fragment. And then comes kind of the filter part, the actual filter part, where it's just querying for managed objects where the name equals norm asterisk. Then, yeah, with parents equals true, that's up to your liking. Also the page size, and we are, of course, starting with the current page being 1. And you can see here the total pages are not of interest for us. And so we set it to false in the first query. And for the other two queries that you would see here, it would be the count queries, where you can see that the page size is set to 1, and one will contain the name filter and the other one will not. So that would give you the count of all the elements that you have in here. Okay, now let's just check how is this being set up. So start with the HTML. You can see it's very small to keep things simple here. I just specified the title. I would not need to. It would then fall back to some default string. I bound the column definitions that I already covered and talked about what these are. So if I go here in my component, you can see that I have a columns attribute here that is being filled with this content. So we have a column that shows the ID and a column that shows the name. And I explicitly set this to be filterable. So like I said, they are sortable by default. Here. And the name column is also filterable now, since I set it to true. String filters are by default supported for the local approach as well as for the remote data approach. The pagination is also bound here. So what I specified is that the page size should be 30, and of course it should start with the current page being 1, not on page 2 or something. What is also a bit quirky, in my opinion, is you cannot freely specify the page size. There are some pre-configured page sizes in the Cumulocity UI project. And if you do not match any of these pre-configured ones, so like 10, I think it was 10, 30, 50 or something, or 5, 10, 30, 50. If you say 51, it will fall back to the default page size, which is 5, I think. That's a bit of an interesting quirk. So just that you know, typically use 30 or 50. 100 is already not supported. Okay, and so this is the pagination. We do not show any action controls in there. So we do not want to have like editing or deletion capabilities right now. It's just about how to set it up. And now the most interesting part is the server-side data callback. And you can see there's a devices data source here, dot server-side data callback. Let's just quickly go to the component. And there should be, here in the constructor, there's the devices data source that I'm injecting here, public, so that I can access it in the HTML. And I'm accessing an attribute of this data source service. So let's have a look on that. So if I just click here on the server-side data callback, let's see, yeah, it works. And you can see this is already my code because I already abstracted everything kind of away. So it's basically that the hard work is done inside of the inventory data source service here. And all that I need to provide here in this service is the base query. So my base query already mentioned, I'm just interested in devices in the inventory. So this is what I'm specifying here. And this base query will then be sent along. Here's this on data source modifier method that is invoked by the data grid. This will be sent along with the column definition. So if I look here on the data source modifier attribute, you can see there's a columns attribute, which consists of a column array, search text if you would have a search, the current pagination and some selections, but it's usually not that interesting for you. Yeah, and what I just do is that I then call my generic or general inventory data source service and give it the current specification of the data grid. So like I already mentioned, for each and every column of the data grid, you can find what is currently filtered or sorted on. So let's just jump into the inventory data source. This is a lot larger, as you can see. And in here, you can see the reload method. This is then, so to say, invoked by the device data source service. And the device data source service, in turn, is invoked by the c8y-data-grid, since we bound it using the this server-side data callback attribute here. So this is kind of how this is chained together. Why did we do it like this? Because by using this approach, you do not need to implement out this whole inventory queries. It's always the same kind of, because you always have to query for managed objects if you want to target inventory, of course, and you always query for the counts. And that's basically it. So these queries will always look the same. But the only difference is the filter query that is inside of these queries. So that what you can see here with ... query. This is the dynamic part, so to say. That's also why it's being put in from the outside. And that's also what is being generated here by these methods, create query filter. So you can see here, create query filter. What does it get? It gets the columns, so the array of columns, and our base query. If I go into this method, what it does is it reduces the array of our columns to just one filter query object. Where you can see you have the __ filter and the __ order by. And the filter will then contain our query JSON. And this query filter here, query, this query object will then be put in the queries util, which in turn will create the query string. So this is exactly the part that I try to abstract a bit and to show you by showing you, one moment, where do we have it? Here. This is exactly the part where this happens, that it would generate the JSON structure, and the JSON structures you can find in the query playground, how they typically look like. Then you run build query on that. This will generate the query string, and this will then be put into the filter object that targets the inventory. I always think this sounds super complicated. I hope it doesn't. But this is also what just this method here does. It converts the array of the columns with the filters and the sortations being set just into one object that has one attribute, being the query one. And this will then be put for instance, if we go here for manage objects for page, you can see here, this is exactly the one that is then being put in here. So that here, in theory, you would have something like this query, and then whatever the query looks like, yeah, with $filter equals. So this is basically what happens behind the scenes here. And this is the whole magic of this, so to say. This is how it's being done. So it's generating the query filter. It's creating these 3 queries here. And you can see it's very well abstracted already. So fetch managed objects for page, where you give it the pagination information from the data source modifier attribute, give it the filter query that we just created. Then we have the count, where with the number, so to say, you can also see that here, it's returning a promise of type number. I can also just go here. It's looking better, I guess. And also the total count, which does not have the query filters in it, and just but still uses, of course, the base query. That's what you can see here. The all query is that you do not give it any of the column definitions, but you still give it the base query. So it does not return you the total number of all managed objects inside Cumulocity, but just of the ones that are devices in this case here. And then all of these 3 requests are being performed, so to say, and that's what you do with promise.all. It just makes sure that all these 3 requests are done and we received the results. And that's what we will combine inside of the server-side data result. So nice that they created also an interface for that, so that you can see how this is being, what it consists of. And you can see, again, it consists of the results. So the size, filtered size, size meaning the total count, filtered size, the count matching the query, and the managed object, so the result data set. And that's basically the result that the data grid gets. And this is the whole principle behind that. If we just look here, what happens here is there are also parts, but this is something I have not covered yet, and we will not have time for that. If you intend to create a custom filter view, what you need to do then is, or how we typically do it, is that you will create this query JSON. You will create it inside of your filter, of your custom filter view component, and you will write it into the column dot external filter query attribute. So like already mentioned, everything is stored at the state, so to say, of your grid is always stored in these columns. And what you do here in the service now is that you would just kind of consume whatever was now configured as external filter query, and will just append your filter attribute with whatever was configured in there. You will just extend it. That's also why it's called extend query by column. So you can extend in the query the filter, as well as, I guess, no, not really the sortation. It's not extended because there's no custom sorting or something.
Henrik, you have 5 minutes.
Yes, yeah, so basically I'm done here. I explained everything. If you are still interested in more, let me know. Yeah, again, room for questions, if you like.
Anyone?
Yeah, this is Felix. Maybe one question from my side. So Hendrik, the next time I use the data grid and I want to do some inventory querying or server-side filtering, I can basically take the code you just showed and add the base filter and do it, right? So this should be quite straightforward.
Exactly. For instance, if you would fetch groups instead of devices, you would just need to change the string here. That's already it. It gets just a bit more complicated, for instance, if you're not interested in managed objects, but for instance, you or if the list query is not the correct one for you, so to say, because there are other queries, right? There's also like, give me the child assets of a managed object or something like this. Then you would need to create yourself a new data source, or you could just change that here, where you would just change here from list to child assets. or not child assets at, but child assets or something, or lists. How is it called? I don't know right now, but child assets list, I think it is here. And then you would retrieve the child assets of a managed object, for instance. But yes, you are absolutely right. So it's very easy to reuse this. That's also the reason why we set it up like that. Just that you know, I also created here a data source for measurements that you could also use here, measurements data source.reload, where it's doing everything. It looks quite the same, right? So you again have these 3 queries, but then it's just using the measurement service.list. And you can see there are also queries, but there are some private queries that you can also use with the measurements data or with the measurements API. Right.
Okay, thanks.
Will you maintain that, Henrik? So if the web SDK is changing or the query is changing, will you maintain that?
I try to.
Okay.
Yeah.
Good to know.
Right now it is up to date, so to say. I mean, what I could potentially then replace is these count queries that because I have seen that there are in the API documentation of the REST endpoints, there are now dedicated count endpoints, but I need to see if this works for the data grid. Because right now the trick is always to set the total pages to 1, which is, I guess, not the finest solution.
Yeah.
And what I also have totally not covered is in the customization example that you see here, that you can even reduce the amount of requests to just 1, because in here I'm not showing the filter section, the filter header on top. I'm not using pagination, right? I'm just using a load more button. So I do not need to fetch the counts. I just need to fetch the actual data set. So I'm reducing the amount of fetch data by 2/3 because yeah, I just need to fetch the data set. It's also quite interesting. So please check it out, customization example. There you can also find cell formatters like here that you can create links and create these custom filters here. Yeah. Okay. Any other questions?
Last chance.
I don't have a question, but just a comment, Hendrik. This is a great thing. I will try to use it and I will let you know how things goes with my project. Awesome work. Thank you.
All right. Yeah. You're welcome. So I'm always glad to help. So if anyone has a question here in this group, and please also share the word. If anyone ever runs into problems using the data grid, please feel free to get in touch with me and I will help you out. That's no problem.
Perfect. So we are already in time. It's 3 p.m. So thank you very much, Henry, for presenting the data grid. Thank you everybody for joining the today's event. Hopefully we see you soon in one of the next events. And have a nice day. Bye. Here. Bye.
Bye.
Thank you. Bye.